Hello, everybody. Hey, this is going to be question number 6 out of your homework, and this is a more complicated version of this integral right here to find the center of mass. So we already know the center of mass is equal to 1 over m of r dm. Now, you guys, I put x dm here because the distance there is going horizontally. So we can put x. If it was going y, we could do y. It doesn't really matter, but that is that equation. Now, just to reiterate, remember the problem with this equation here is that this x and this dm are not in the same variable. So we cannot integrate it yet because they're not in the same form. So that's what we need to do. And what we did before that you saw in the video from a couple videos ago is we used linear density, and linear density is mass over length. Then we get to dm over dx, because the whole thing divided by the whole length is the density, but it's also this little bit of density divided by this little bit of width, and they're the same ratio. Okay, so we can then just cross multiply, and we can get dm is to y dx, and then we can plug it in here and get it into a differentiable form. So that is the same thing. That's the same thing we've got to do for this more complicated one. Now, if you read the question, it says Pat is going to build a model track for his model car that's going to go down. So this ramp right here, that curve right there, is a parabola that is equal to x minus 3 squared divided by 9. Okay? So we want to find the center of mass there, but this is going to add a couple bit of complications. So again, we're going to start out with x center of mass is equal to 1 over m times the integral of x dm. The biggest problem right away is that we do not know what the overall mass is. We do not know what the overall mass is because it's not a regular object. It's not a regular object. And that object is going to vary. Okay, it's going to vary depending on how much we have. Now, you guys, what we have here is that now we want a area density. We want an area density, just like here we had a linear density. So you guys, I'm just going to call this area density, because I'm going to call that alpha. Again, there's no magic as far as what that symbol is, okay? But that is going to be the mass divided by the overall area. Now, we also know that if we take this section right there, okay, that would be dm. That would be dm. And so we want dm over the area, you guys, and the area of that is going to be y times dx. So now we can say that dm is equal to alpha y dx. And we also know that y is x minus 3 over 9. So alpha times the quantity of x minus 3 squared over 9 dx is equal to our dm, okay? And we know that mass is equal to the integral of dm, right? So dm is the differential. This integration sign is anti-differentiation. So if we take the anti-differential of the differential, we just have the mass, okay? So now I'm going to kind of switch, and we're going to do this. We're going to do this integral over here, okay? And So we're going to say that mass is equal to the integral of dm, okay? And let me switch us over here a little bit closer. Okay. All right. And we also said that that is going to be the integral of alpha x minus 3 squared divided by 9 dx. And we're going to do that from 0 to 3. Okay. Now remember, the 3 came from that the length of this model track is 3 meters long, okay, which was given in the problem. All right, so you guys, this alpha is a constant. This 9 is a constant. So we can bring those out. We can put alpha over 9, okay, and we can expand this x minus 3 squared by foiling it. And when we FOIL that, we're going to get x squared minus 6x plus 9. Okay, now it is dx, and now we can, you guys, we can we can integrate that, okay? And when we integrate that, we're going to take our x, we're going to raise the power from 2 to 3. We're going to raise it by 1. So 2 plus 1 is 3, and we're going to divide by whatever we raised it to, okay? So now we're going to have minus, this is a 1, so that's going to be minus 6x squared. 1 plus 1 is 2, divided by that, whatever we raised it to. Now, this one right here is 9. You guys, this is 9x to the 0. And so we're going to raise 0 plus 1 is going to be 9x, and then we're going to divide that by 1. Okay, and now we are going to evaluate it from 0 to 3. So we're going to plug in this 3. We're going to plug in this 3 into all these variables, 3, 3, and 3. Okay, we're going to take that whole thing, and we're going to subtract it. We're going to subtract it when we put in 0. Okay, it's another way of saying the final minus the initial, which is the change. Okay, now obviously you can see that when we put in the 0 is just going to drop away. All right, so we're going to say 3 cubed. 3 cubed is 27, so we're going to say 27 thirds minus 3 squared is 9. 9 times 6, well, we can actually reduce this to 3 because this 2 will reduce. So we're going to say 9 times 3 is 27, so minus 27. 3 times 9 is plus 27, okay? So these two cancel out. Minus this whole thing when we put in 0, which is nothing, so that's minus 0. And this whole thing times our pi over 9, our pi over 9. We can also see that now these two 27s cancel out. 3 goes into 27 9 times. This 9 and this 9 cancel out. So our mass is equal. Our mass is equal to our area density. Our area density. Okay? So now we know when we come back to this equation right here, okay? Well, let's get that over here. This 1 over m is going to be 1 over the area density. Okay. All right. So we still, you guys, we still have this problem of what dm is. Okay. And remember, we know that our dm is equal to alpha times the quantity of x minus 3 squared over 9. Okay. So now when we plug this in, we're going to have 1 over alpha, because we figured out from over there that our mass was equal to alpha, okay, times the integral, again, for going from 0 to 3 of x dm. And we know dm is alpha x minus 3 squared over 9 dx. Okay? Now, we again know that alpha over 9 are constants. Okay? So we can say alpha over 9 comes outside of the integral. Okay? And we also have 1 over alpha due to our mass, and that means these two alphas are going to cancel out, and now we're left with x times the quantity. If we expand this out again, that's going to be x squared minus 6x plus 9. Okay, and then we've got a dx in there, which lets us know that we can, all those variables are in x, so they're all the same. Therefore, this is an integratable function. Okay, so let's take this down here, and now we're going to have x times x squared is x cubed minus 6x squared plus 9x, integral of 1 over 9 from 0 to 3. This is all dx. So now we can integrate it, okay? And when we integrate it, okay, 1 over 9, the integral, okay, is going to, well, once we integrate it, we're going to say x to the 3 plus 1 is 4 divided by whatever we raised it to, minus 6x cubed over 3 plus 9x squared over 2. Okay, and now we're going to evaluate that. We're going to evaluate that from 0 to 3. Okay, so again, it's going to be, we're going to take this variable, plug it into everything, minus when we take this and plug it in. Again, easy, because when we plug this in and we put it all in there, it is going to cancel each other out. So, and then at the very end, we're going to multiply by 1/9 here. All right, so 3 to the 4th power is 81. So we're going to have 81 fourths. Okay, 3 cubed is 27. We can multiply that. So 27 times 2 is going to be minus 54. We're going to say 3 squared is 9 times 9 is 81 minus 81 halves. Okay, so let's find a calculator here. So we're going to say 81 divided by 4 minus 54 plus 81 divided by 2. This is going to give us 6.75 is our answer to this. Again, we plug in 0, that's going to go away. And then now we're going to just have to multiply this by 1/9. So 6.75 divided by 9. And that is going to give us 0.75 meters. And that is the location. That is the location in the x direction of where our center of mass is. So this whole thing was 3. So that's about 1.5. So somewhere around here, okay, is going to be the center of mass in the x direction. So that's 0.75. Now, you guys, that will suffice. But if we want to do that in the y direction, to calculate the center of mass in the y direction, we're going to do the same thing. We're just going to do it in the y direction as opposed to the x direction. So that would be y center of mass is 1 over m of y dm. And then we can go through the calculation and to figure out what that is. All right. So that is going to be it for problem number 6. And I hope this made sense. And if it didn't, you can just kind of go back and forth and work on that. All right, take care.